working with big data. So what is the HDFS? So by Google file system, how the data is going to be observed and monitored, how the replications is going to be happen. And one of the important thing is HDFS building blocks of Hadoop. So even if in the fourth unit, Hadoop input output. So before going this, here we are going to be seen about the basic again, the data node, name node, secondary name node. How about this job tracker and the task tracker? Everything we are going to be discussed again in the view of Hadoop. So generally we discuss about individually. So we discuss Hadoop building blocks separately, and how to write a map reduce program with mapper and reducer functions. So these two, how we are going to be implementing Hadoop input output. So that we are going to be discussed in the fourth year. So that is a Hadoop input output. What we are going to be give the input to Hadoop and what we are going to be get an output. So what is the Hadoop architecture? Everything we are going to see. So in Hadoop only we are going to be the new tools, the Pig and the HiFi. That is the next fifth and sixth chapter. So that will be learned later. So the fourth unit is about Hadoop input output. So this simple meaning of this Hadoop input output means the second and third unit combined. Second and third unit combined. So second unit, what we are going to be learn overall is just we are going to be learn about how the data is going to be storing. Listen, the name node, secondary name node, data node, job tracker, and task tracker. By using this, we are going to be create a node. Later on, we are going to be create some replications. What is the need of replications? What is the need of replication? So if any main server or main system is crashed, in order to get back the original data, we are going to be maintain these replications. What is the minimum size of replication? 3. So even if the size, everything, how the data is organizing. So I already shown some diagrams how the systems are rack systems, maybe in a spatial systems, how it will be aligned and arranged in a server rooms. I shown all the diagrams when we are discussing briefly about these chapters in the last classes of these 3 units completed. So these are the things we discussed here. Unit 3 is how to organize the memory. What organizing memory? What we are going to be organizing here? The thing is, we have a large amount of data itself. How we are going to be organized? How we are going to be stored? Once we are storing, so how we are going to be get back that information? I already told you, whenever we have a concept of memory, what is the meaning of memory? It is not only storing, it is also a retrieving. Then only it is an efficient way of organizing memory, we can call it. Yes, sir. So we are simply storing the data in memory card or hard disk. What is the need of storing? So how much speed of storing? The same way or the same speed we have to retrieve the data. Then only we can call that is an efficient memory organization. So once in the second unit, we learned about how to organize, how to store the data. In the third unit, once the data is stored, so even here we are not going to be talking about a single 1 GB, 2 GB of data. Here we are going to be talking about petabytes of data and petabytes of data. You know what is the size of petabytes and petabytes? And the last one is yottabyte. You know the size is very, very large. If the large size of data is available, how we are going to be get back with retrieving? That means, so the person who is searching in a Google, the person is to access the total Google data is going to be accessed. No, by searching up, by giving a query, he is going to be. Query means either maybe it's a typing or voice command, whatever it may be, something is going to be give a command to the, that is a user requirement. So based upon the user requirement, the data is going to be retrieved from the large amount of data. So that is the retrieve. So that is here the simple way of retrieving or representing or showing the data at user end. We are going to be writing MapReduce code. So here we learned about how the weather set data, how we are going to be done, and word count, how we did, everything we did. So if these two we are going to be combined with, how the Hadoop input output system is going to be designed, that's the thing we are going to be discussing. Okay. So I think you have an general view of what is this second unit and third unit, how we are going to be moved towards the fourth unit. So before going this, that's only I gave a simple explanation about this unit. Now I am going to be show you one diagram before going to be this fourth unit. By that you can understand. In the fourth unit only that also. So I think my screen is visible to everyone. The diagram is visible to everyone. Don't go with the overall diagram. Just see about this blue color line from last to fourth one. Last to fourth one. Have you observed here the data storage framework and another one is data processing framework. So here we have two frameworks. These two frameworks only we already learned. So this is the second unit and this is the third unit. This total we are going to be using in Hadoop. Okay. So the data storage framework, how we are going to be storing the data. So again I am telling. So here we are not going to be storing a single GB or 1 GB or 2 GB. Not only a less amount of data, it is a large amount. So once we are stored, then how we are going to be processing data processing framework. So by using a MapReduce. So but these two we have some JVM, Java Virtual Machine, and some operating system. So these are the things we are going to be used aside all those things. So this is a total framework of Hadoop. So how the input and output is going to be organized. Okay. So now we can start with the fourth unit. What is this fourth unit? See this is the fourth unit. Hadoop, a distributed framework for big data. A distributed. So we know the meaning of distributed. We already know about Hadoop distributed file system. How it is different from distributed file system. We already learned also. So what is the distributed file system? So here the data may generating or storing in a various forms or various getting and storing in various places. So how it will be? Maybe data is generating various places and storing in one place. Or data is generating one place and storing in different places. So both we have a different meaning. So for example, if I am generating a data that I am going to be storing in Google, maybe I'm going to be store my data in a website. The website may access by number of people. So the one to many. For example, so say like me, so some other users are working in one group of companies. That may be, for example, every 10 members are going to be organized one website. The 10 different members are generating a different data and storing into the website. That website may be used by the number of people. So how we are going to be distributed? So that is alternative and the main objective of this distribution. So even these type of systems are available in the previous days also, but where the data size is very, very less. We already discussed that how the data size is rapidly increasing nowadays. In the past decades, how the data was increased rapidly. I shown you one diagram. So, what is the size of data? How it is going to become? We need to know that the size of data in the DVD size. So, it may be at the end of 2020 or 2030, the size of data is triple or double, triple or force of the previous day. Now the increasing in the data is per day is very, very, very high. So that we will discuss here. We will have some simple PDF also. So what is an Hadoop? What is a Hadoop? So Apache top level project. This is a Apache project. It's an open source implementation framework for reliable and scalable distributed computing and data storage. So reliable, scalable, and distributed computing and data storage. So how we are going to be organize the data. So organizing means in the sense how we are going to be storing and how we are going to be retrieving. So that also here we have very clear how the reliable and scalable. What is the reliable data? So have you heard that flexible in the same manner only, flexible, reliable, scalable. Whenever we are going to be talking about the features of Java, have you learned this? Java is a flexible, reliable, scalable. Have you heard the same? So whenever we are going to be design or creating a program, what is the ultimate aim of a program or designing a software, whatever it. So in order to reduce the number of minutes of time to compile and the size of the program is less. So how much easy to understand to others. So that the things we are going to do. So this Hadoop is developed by Apache. We know already Apache Tomcat. That we know that the servers are there. So the same team was developing this Hadoop system. So it is a flexible. Again, I told you the term flexible, reliable, and scalable. These are very popular term whenever we are going to be talking about the features of it. So flexible and high available architecture for large scale computation and data processing on network of commodity hardware. Network of commodity hardware. So commodity in simple means is cheaper and easy. So even if data is storing in a RAID server, it was a very high and even it like this. So we are going to be using that modifying, simplifying data in a simple mobile also we are going to be seeing at our end user end. So if these things are going to be like this, how, for example, the simple, what is the mobile cost? Maybe we can view a web browser. Even if we can geophone also, we can see the browser. There also we can search something. We are giving some query to Google and we are going to be retrieving data. So what is the cost of the simple Google or else Google enable mobile? So compared to that storing of RAID servers, all those things is very, very, very minor. So if it is like this, that is a network commodity hardware, then how it is going to be cheaper to access the data. So what is the meaning of flexible? So in order to anyway we are going to be access that large amount of data to a single or a simple giving a simple query to access the. So that is it is. So see there is some beautiful diagram here. So what is the spider we have? So that means every data is going to be connected one to another. Every every data is going to be connected one to one, right? Maybe, for example, we are going to be getting through one key. The key is going to be access to another and another. Have you heard that keys? What is the need of a key in the table? I remember. You already come across about database management system where we have a table, we have a primary key, secondary key, and foreign. I remember. What is the use of a primary key? So through that key, we are going to be accessing any data without a duplication. So key is a non-duplicate element. Through that, we can access a number of things. We can adding or we can deleting through the primary key or any key we are going to be searching. That is very, very important to manage the table. So here also, so designing to answer this question, why this Hadoop is created. How to process a big data with a reasonable cost and time. A reasonable cost and time. So large amount of data is producing nowadays. If the amount of data is increasing, how we are going to be process that big data with a reasonable cost and time? So means cost will be less and time will be cost. So how we are going to be do with this? So that is a ultimate. See that in 1990s, the web browsers are like this. So many we don't have a proper arrangements and everything. You can see that. Have you know already how the Google browser will be there, or Yahoo browser is there, or what are the familiar browsers what we are going to use? 90% of people are going to use Google Chrome or Google browser. We don't see this type of jumbling orders and this type of so many advertisements at the top page. See that? Can you, by seeing this, can you say this is a browser? Can you say that this is a browser? Something words are in the page. That's it. Can you feel that this is a browser? In the previous times, this is the 1990s. This was a browser where we are going to be used. Everything is going to be managed in a single page itself. Simply, it is clicking, it is going, and that's it is a browser. We don't have any extension. So, what are the things we are going to be mentioned? That the things are mentioned in the particular page itself. So see here in 1990s, see that. So are you searching for a phrase or searching for words or searching for any of this? So they're searching also we have an optimization. These optimization also now are done at a Google search. We don't have any such type of just we can simply giving a query. Then we have maybe you can give searching something name which is familiar. Nearly we can have nearly thousands of search related things will be displayed. Have you observed the downside we have? So page 1, page 2, page 3. It is Google search. In 1998 we have like this. In 2013 is like this. So what you got the difference from this? So here we have some specifications. Here we have all those things are included there itself. By using search itself, it's going to be generate all the data. And here we need to confirm with what is this, what is this. Now this any important data, anything is going to be mentioned as a separate one. So here it is not like this. We need to go with this specific one, specific things on this one. Everything like this. So it is Hadoop developers. John Cutting and Mitchell J. Claripa is developed Hadoop to support a distributed for Natch search engine. So this was a search engine for previously developed for Hadoop system. So Natch search engine, it is a one simple project. The project was founded by Yahoo. The Yahoo get this project from Apache Software Foundation. We already starting itself they said that the Apache was developed this Hadoop system. So gave that project to Apache Software Foundation. So this was a Hadoop distributed file system, Hadoop MapReduce system. So Google file system was used and simply reducing on large clusters. And then later on, Apache, HBase, Hadoop base. So these are the various generations of in 2003 to 2006, how it was implementing this Hadoop. Simply first one is about file system, then the later on how we are going to be doing the MapReduce, the later on is how it is in HBase. So these main milestones from 2008 to how it is booming like very fast. In 2008, the Hadoop wins the terabytes of sorting benchmark. So this is a simple meaning. Sorting of 1 terabyte of data in 209 seconds. What is sorting? The simple, for example, we have 1 GB, 1 terabytes of words are there. So in order to sort the data means from ascending or descending order, we may select it and we are going to be sort the words. In 2008 was taken to 209 seconds compared to the previous records 297 seconds. So it nearly reduced how many seconds? 80. How many? 86 seconds was reduced from previous to this one. Then 2009, Avera and Chakov became the new members of Hadoop family environment. So previous the two scientists are there from these Dong Cutting and Mitchell J. From these 2005, later on 2008, start in a benchmark. That means the previous where is developing stage. In 2008, it got a benchmark. Simply we can say what is the breakthrough? The same meaning here. The benchmark means they said that so 1 terabyte of data. So previous in 297, so it is reduced to 209 seconds. So there I place some benchmark for this. Then 2009, some more two members were joined this family. In 2010, Hadoop's HBase, Hive, and Pig sub-projects were completed, adding more computational power to Hadoop. So I will show you that architecture diagram what we saw in the starting class. That I will show you again. These words were implementing in a Hadoop architecture. In 2011, Zookeeper was completed. These are everything is a part of this Hadoop structure. In 2013, Hadoop 1.12 and Hadoop 2.0 alpha. So that is Avani and Casada and Mutut have been added. So everything system will be added. So simply we can say that updates. How we are going to get the update from one app. The same way here, Hadoop is getting adding services. So first one it is about simply sorting the data. Then later on, they were added HBase, Hive, Pig, and all these sub-projects were added, and the Zookeeper was added. And later we have some more versions are there: Hadoop 1.12 and Hadoop 2.0.3 alpha versions. So Hadoop is a open source software. It supports the data-intensive distributed applications licensed under Apache version 2 license. It is going to be run on Apache version 2. So what is these main goals of this system? Abstract and distillate the storage and processing of large, I already told you, very large or rapidly growing data sets. Here the data sets are continuously getting the data, rapid number of that simply meaning means for example, can you say that any data set is going to be ended? For example, what the data sets we previously discussed, the word count, water it will be. So we saw about the some weather data set we saw. So if the sensors are continuously monitoring, getting the data, what is going to be happen? The storing of the data set, the data size is very rapidly is increasing. So even if we saw some of the statistics of this big data, we saw about some cricket page. So who are all the players? So what is the size of the team? We need to know about what is the players runs and wickets or centuries or these. So this continuously it is going, it is continuously it is going, and the data set is going to be increase and increase and increase. If it is going to be like this, what is we need to implement some more technology, new technology to add and add every time. That is why, because again the data may be structured or non-structured. So for example, simply we are going to be typing the data as previous. For example, we need to add internal 1 marks, and we need to continue internal 2 marks. We can add down as is. So if the format is there, in the format we can definitely we can do. If it is not like that, for example, every data we are going to be get it from scanning, or we are going to be collecting from cameras. How? So each and every time the cameras are getting the same track of data. Each and every time the sensors are getting the same track of data. So that is it. So again, the data is, we know what is the structured, semi-structured, non-structured data, how it will be. And simpler programming models also we are going to be developed here. Then we know what is the scalability, flexibility, all those. High scalability and availability. And use of commodity, and this, that is commodity hardware, cheaper hardware with a little redundancy. Then another very important is fault tolerance. What is this fault tolerance? Have you heard this word fault tolerance? Have you heard that word fault tolerance? Where we started about this, why we were adding these replicas. There we were know about the fault tolerance. Even the one system is fails, the data is going to be retrieved from the another system. That is another node, we can call it a node. So it is a fault tolerance. Move computation rather than the, so we can move to computation. We are not going to be stand on one particular data. We are going to be get the more number of data to adding one to another. So this was the architecture, the present Hadoop framework. So everything was included. See the fetch-based, Flame, and Jupyter. So these are the abstract of framework. Then the data accessing frame. So everything is in a simple separate frame. Every frame we are going to be adding into Hadoop system. So see this. So this EW connectors, how it is going to be connecting this. So business intelligence application story. So this is have you heard this? What is a business intelligence application? Giving query analytics, reporting stats. The ultimate aim of this big data is output is how we are going to be showing our data to users very clearly. So these are the framework about how we are going to be arranging the data and how the data going to be access the framework. So any of one we can use and we can access the data access. So through the network we can access all those things. Network is placing a major role here. Then the data, how we are going to be data storage is there, how the data storage is going to be happening. And once the data is stored, how we are going to be processing, how the JVM is helping for this, and the operating systems, Linux operating system, and various all those things like that, fund recovery and deployment and security and management, how these things. So we can may add it some more things here. So maybe advanced versions will be okay. So based on many parts we find out from the previous architecture, the new things is going to get introduced. So distributed with the same centralization. So some centralization. What is some centralization? Centralization means so that this main task of this one, storage and processing of data, is some centralization. So remaining things are going to be added to in order to process the two things are there, the cost and time, reasonable cost and time. So in order to achieve that goal, those more things are going to be added to this. So distributed with some centralization. The main nodes are clusters where the most of the computational power storage to system level. So how we are going to be store and manage. The main nodes are to run the task tracker, to accept and reply to the map retrieve task, and also data node to store the nodes blocks closely as possible. We know what is the data node and what is the secondary name node and what is the name node. Then central control nodes name node to keep track the HDFS. So what is this keep tracking nodes, running nodes are? So you know that everywhere here in a data node, secondary name node, and other one is job tracker and task tracker. We have receiving heartbeat messages each and every time. I remember these word heartbeat messages. What is the heartbeat messages? So each and every time we have reply back from the query. So whether it is going to be getting or not, each and every time it is going to be continuously getting messages from maybe you can call a client to server. We can continuously we have some heartbeat messages is going to be sent back, getting and back from one to another. So written in Java, it's also support Python and Ruby. So it is not only supporting with Java. So generally it is written in Java, but it supports the Python and Ruby languages. So have you observed this diagram? This diagram was previously explained also, but in a different manner. By seeing these downside lines, rack 1 and rack 2, rack 3, rack 4, rack 10, where we saw this rack 1 and rack, this rack 1 and rack 4, where we created replications, where we have a rack 1. So we are going to be keep the replications, all the replications, not only one rack, we are going to be the replication nodes in this some other places, not in the same rack. Different diagram I shown in the second, third image. Where the replications are going to be maintained. So the default size of replication is 3 nodes. Then where we are going to be store the 3 nodes in different places. Even there we have some simple calculations also. So if 5 nodes are there, how many nodes we need to create, how many racks we need to create. So what is the size of replication? Based upon replications, how we are going to be manage and maintenance all this. So everything is up. So what we have is various features. So then data node, name node, job tracker, secondary node, client, how we are going to be. Data is going to be transferred from data node to transferring from one place to another. So that is the switches. So Hadoop architecture, Hadoop distributed file system. You know about what is this distributed file system? DFS we already discussed. A trailer need to a map reduce. Trailer need to a map reduce. And target towards many reads of file streams. So main objective of this Hadoop is target to towards many records from file system. Returns are most fast, more fast. Writes are more fast. High degree of data replications. So that is a 3 into by default size. So the replication is default size is 3. No need of a RAID on normal nodes. Have you know that this RAID model, RAID 0, RAID 1, RAID 2, have you observed this one? RAID levels, hierarchical levels we were operating system. We learned about it. It is a RAID 0, RAID 1, RAID 2. The levels of how the hierarchical level, paging concept we were learned about. What is the page path, everything there we learned. So here we are not going to talk about any RAID. Then large block, we know that one block size is 64 MB size of the block. And the location awareness and the data node in the network where the node is available. So awareness of where to where it is going to be sending and transferring, everything is going to be. So we know these wordings, name, node, these are things only again. Before going to this, I will give you time to go back with the name node, secondary name node, job tracker and task tracker. Everything you can refer from the unit 2. We know the basic blocks of Hadoop. You can refer and we will start this one again tomorrow. So what is this node? So even we can start tomorrow by starting the class. We can have a brief discussion on the second unit is Hadoop building blocks. Then we can back to this. Okay. So anyone having doubts so far? So can you tell me? Then we have 5 to 10 minutes. We can have doubts and we can find out. Anyone? So please everyone go through your Google Classroom and update your assignments. This is what we have left. So everything what we are doing is about your data backup files. We have everything we needed to. So actually we are managing such type of LME systems. So please everyone go and complete the assignments. So anyone having doubt? Can ask me. Or else shall I ask you about what is? Shall I ask you questions? So this is mandatory. Please everyone go clearly and ask them to join process. 45 of 95 members or not. It's very ridiculous. So CS, make a note and ask your students to join. So anyone having doubt, you can ask me. Shall I ask questions? So before coming tomorrow class, you can go and refer the unit to what are the basic blocks of building blocks of Hadoop system. Building blocks of Hadoop system. So we have mainly 5 we have. data node, name node, secondary name node, job tracker, and task node. Don't refer those. Come to your class, you can know everything, and you can learn, you can discuss, and we will have some small discussion over that. Then we will come to this chapter again. Just ask me if you have any doubt, you can answer. So wait for 5 minutes. Any time you can ask. Else, you can leave. So today we discussed about Hadoop architecture, Hadoop distributed data. So this is an Hadoop. So we were developing this. So Apache was get from the Hadoop. So it was mentioned here. So in 2006, Yahoo gave a project to Apache software. So before that, this was running in search engine project founded by Yahoo. So later on, this one we gave it to Apache software. And here we have various implementations of this advanced Hadoop distributed file system, Hadoop MapReduce, and Hadoop HBase. So each and everything was developed in various years. The implementations, then various milestones. It was very very important. How the starting time of this 1 TB of data. Then various sub-projects of Hadoop HBase and Hive and sub-projects were there. And two features. Then what are the requirements and goals of Hadoop? Requirements and goals of Hadoop. So it is a commodities hardware. Then there is a main architecture of this framework tools. All those tools were included. Then Hadoop architecture. How we are going to be switching. How the new data for maintaining. So this we will discuss. From tomorrow, everyone please go through the Unit 2 Hadoop building blocks. Then we will start. So time changes in timetable, please everyone remember. The third page was going to be from 11:10 to 12. So please note everyone. According to timetable, please attend the everyone classes. Don't miss your attendance. Okay, if you don't have doubts, you can leave the class. And I will end by Okay. Thank you.